The toughest deductions are the indirect deductions that we shall now introduce. These deductions are called indirect because during the deduction we make a temporary assumption which seems to come out of the blue. In a typical indirect proof, often called reductio ad absurdum, we want to prove A and start by making the temporary assumption not A. If we can now derive a contradiction, we know intuitively that A must be true as not A leads to a contradiction. Strictly speaking, what happens is that we get not A by the negation introduction rule, and then we let the two negations cancel each other out. For this to be permissible in a deduction, we need a new rule, a negation elimination rule, which we shall now introduce. The negation elimination rule is the rule that if we have derived not A, then we can conclude A. Let us repeat the reasoning behind the negation elimination rule. The reasoning is extremely simple. Assuming negation A means assuming that it is not the case that negation A, so it must be the case that A. Because, well, either A or negation A has to be true, so if it is not negation A, it must be A. This reasoning is often called reasoning in classical logic, because there is also a different kind of logic, non-classical logic. In fact, non-classical logics come in different varieties, but a common feature to them is that they are not based on the idea that there are just two truth values. A famous example from Aristotle is the sentence, quote, "Tomorrow a sea battle will take place," unquote. Let us call this sentence A. To say that A is true seems unfounded, as something may happen which makes a sea battle impossible or unnecessary. Should we then accept not A as true? This seems equally unfounded, simply because we do not know what tomorrow brings about. So it seems most reasonable to say that neither A nor negation A is yet true. The sentence A is an example of a formula of temporal logic. We have now introduced the two rules that govern deduction about negation in propositional logic. The negation introduction rule and the negation elimination rule. Let us derive A implies B from not A. To prove A implies B, we assume A. From A and the assumption not A, we get A and not A, that is a contradiction. By the negation introduction rule, we get not B. We could eliminate the assumption not B if we had made this temporary assumption, but we did not. By negation elimination rule, we get B as we wanted. Now we can write the deduction easily. We make the temporary assumption A. We use the assumption not A and the conjunction introduction rule to get A and not A. We use the negation introduction rule to get not B, and then we use the negation elimination rule to get B. So from the temporary assumption A, we have derived B, and we can use the implication introduction rule to get A implies B, and at the same time we can eliminate the temporary assumption A. We derive A from the negation of A implies B. This is a typical indirect proof. We have to prove A So we make the temporary assumption not A. In a sense, we check how would the opposite of A, namely not A, fit our situation. So we assume not A. As above, we can derive A implies B. From the negation of A implies B, we get a contradiction. So the assumption not A has led to contradiction, and by negation introduction rule we get not A. And at the same time we can eliminate the temporary assumption not A. By negation elimination we get A. Let us now draw the natural deduction of A from the negation of A implies B. So our assumption is negation left parenthesis A implies B right parenthesis. As was our plan, we make the temporary assumption not A. We try to derive a contradiction and then we would be able to conclude A. As above, we can now use the temporary assumption not A to derive A implies B. So we repeat the steps. We assume A as a temporary assumption. We get A and not A. From that we get not B by negation introduction and by negation elimination B. And we have now proved A implies B and the temporary assumption A is eliminated. So we still have the temporary assumption not A. But we are close to a contradiction. We have derived A implies B, and we have an assumption which is just a negation of A implies B. So when we put these together, we get negation A implies B and A implies B. That's a contradiction. So the temporary assumption not A has led to a contradiction, and by negation introduction rule we can derive not A, and then finally A. We derive B and not B from A and not A. This looks a little odd, but it shows that it does not matter which formula you have in a contradiction. From the contradiction A and not A, we get not B by negation introduction, and then B by negation elimination. Note that we have to go via the double negation of B, because we do not have a rule which would allow us to infer B directly from a contradiction. Similarly, we infer not B from A and not A. Now we do not have to go via double negation. Finally, we put B and not B together with the conjunction introduction rule, and we are done.